Hey, welcome back to Common Core Algebra 2. We're on this freight train through Unit 13, so my apologies that we're going so fast here, but I need to subject you to a little bit of these statistics because it's just such a big portion, and I don't find it terribly difficult, but there are some aspects that you might find a little bit more challenging, so make sure you're asking questions in class tomorrow because we are going to go right into 13.4 tomorrow after we answer some questions on 13.3. So basically what we're going to do today is we're going to talk some more about the normal distribution. I didn't give you an extra handout. I did put this normal distribution on the back sheet of this lesson so you could see what it looks like and use it. You're going to have to make sure you are recalling these numbers, and if you kind of do what I'm doing today where you're constantly writing it out, you'll probably be able to remember them a little bit easier. All right, so let's take a look at exercise 1. Exercise 1 says, for a population that is normally distributed, find the percentage of the population that lies within one standard deviation of the mean. So yesterday we looked at actual data that was within one standard deviation of the mean. Today we're going to look at one standard deviation from the mean under the bell curve. So what I mean by that is, here's my mean, which is right here down the middle. And within one standard deviation of the mean, we're talking about looking from this point to this point. So what we're talking about is making sure that we consider all this information in here, these percentages. So within one standard deviation, you can say this is going to be 15 plus 19.1 plus 19.1 plus 15.0 is equal to 68.2%. So what that means is that 68.2% of the data theoretically lies one standard deviation from the mean. All right? Does that make sense? I hope so. So again, where I got these numbers from was 15, 19.1, 19.1, and 15. All right, let's take a look at B. So I'm going to slide this over here so I can look at B over on the right side. So now I'm looking within two standard deviations of the mean. So once again, here's my mean right down the middle. And I'm looking within two standard deviations of the mean, which is between here and between here. So I want to know all of this information. So all of this here, and I'm trying not to cover the numbers so you can see what the numbers are. So what we're going to add up is 4.4 plus 9.2, 4.4 plus 9.2 plus 15 plus 19.1. Now, if you don't mind, I'm just going to do that whole thing and multiply it by 2, because that will give me the other side. It'll give me this one plus this one plus this one plus this one. And when you do that, you get 95.4%. So that's pretty awesome that you have theoretically, 95.4% of the data laying two standard deviations from the mean. So now C says more than 3 standard deviations from the mean. So what they're saying here is now 3 standard deviations from the mean. It's not saying between 3 standard deviations or within 3 standards, it's saying more than 3 standard deviations from the mean. So what they want is this little piece and this little piece. So that's 0.1 plus 0.1, which is 0.2%. Of the data lies outside of 3 standard deviations of the mean. And we're going to look quickly at D. Between 1 and 2 standard deviations above the mean. So between 1 and 2 standard deviations above the mean is going to be 9.2 plus 4.4. Remember where I'm getting those from, here and here, So this is going to be 13.6% of the data is going to lie between 1 and 2 standard deviations from the mean. Hopefully that wasn't too bad. Let's move on. Exercise 2. Now I had to use Arlington High School because I needed a bigger school. So at Arlington High School, 424 juniors recently took the SAT exam. On the math portion of this exam, the mean score was 540 with a standard deviation of 80. If the scores on the exam were normally distributed, they have to tell you that, answer the following questions. What percent of the math scores fell between 500 and 650? So the first thing I'm going to do is I'm actually going to show you how I do this. All right. I think what I'm going to do is just throw it up there and then I'll explain it. All right. So hold on. So the first thing I do is I create a number line, which is basically, you know, that bell curve would sit over the top of it. So here's the line, here's my mean, because it tells me here that my mean is 540 and my standard deviation is 80. So what I did is I created this grid and I said 540 is my mean, then I added 80, that's my mean plus 1 standard deviation. Then I added 80 more and I got 700. That's my mean plus 2 standard deviations. And then I add another 80 and I got my mean plus 3 standard deviations. And then I worked it backwards. I said now I minus 80 and I got 460. So that's the mean minus 1 standard deviation. And then I have 380, which is the mean minus 2 standard deviations, and I minus 80 again, and I got 300, which is the mean minus 3 standard deviations. So that's the first part of this. All right, so take a minute, write that down, and then make sure I see how I have the intermediate ones there because that's going to come into play. So make sure you're leaving those little spaces in between. Because in A, it says what percent of the math scores fell between 500 and 660. So now if you look, 500 and 660 aren't on here. So then I just realized to myself, well, I have to go in between here. So halfway between my mean and my first standard deviation, at this point right here, I know instead of adding 80, I'm going to add 40. So add 40 on to 540 and I get 580. Add 40 onto 620 and I get 660. There's my 660 that I needed. All right, and then this would be 740. So this just helps me a little bit more. And now I minus 40, I get my 500 here. I minus 40, I minus 40 again, I get 420 here. Minus 40 again, I get 340 here. Minus 40 again. So those are my in-betweens. Now, if you remember what that normal distribution look like, it looks something like, and I'm not going to make it as big, but it looks something like this, right? We're not going to make it quite as large. So what we're going to do is we're going to consider here's my mean at 540. So actually I didn't do this exactly right. Let's see if I can move it over. Oh, that's probably a little better. Okay, so there's my mean at 540. Now remember those numbers, right? This is where those numbers come in. We know this was 19.1. We know this is 15.0. This is where those numbers come into play. We know this is 9.2. You have to know these. This is 4.4, and if you do it every time, you will know it by the end of this lesson. 1.7, this is 0.5, and this is 0.1 out here. And we're going to just do the same thing over here. So this is 19.1. I do this every time. 15.0, 9.2, 4.4, 1.7, 0.5, and then 0.1 out here. So now we can actually do the math. After you do that, that's the hard part. Now the rest of it's easy. So what percent of the math scores fell between 500 and 660? So they're saying what percent between 500 and 660? Well, 500 sits right here between 500 and 660 right here. So let's add up the numbers. It's going to be 19.1 plus 19.1 plus 15.0 plus 9.2. So we get 62.4% when we're all said and done, which is the answer to A. So B says how many scores fell between 500 and 660. So 500, which is right here, and 660, which is right here. Round your answer to the nearest whole number. Oh, this is the same, sorry. This says how many scores. That's the difference, making sure we're reading our questions. Because we know that we had 424 juniors take this test. So if you say 424 juniors times that 62.4%, which is 0.0624, I'm sorry, 0.624, I'm doing my percentage wrong, 0.624%, turns out to be 264.58, but it says rounded to the nearest whole number, so it's 265 students, which is the answer to B. Okay. C says, if Evan scored 740 on her math exam, what percentage of the students who took the exam did better than her? So 740, lays all the way up here. She did pretty darn good. 740 is up here. So what percentage did better than her? Well, only the 0.5 plus the 0.1. So only 0.6% of students did better than Evan on the exam. And then approximately how many students? So out of that, we're going to use our 424 juniors again. We're going to multiply. Now be careful with that 0.6%. Remember, when you have 0.6%, you have to move the decimal point over 2 places. So it's 0.006, all right? And that's going to turn out to be only 2.54 people, but it says rounded to the nearest person. So basically, we're going to say 3 people did better than Evan on this exam. Good for Evan. Now that seemed like a lot of work, but I'm going to remind you that every point that you get is worth the time that it takes that you need to put into it. Okay? So, and remember, if you need to, you're going to write this out. You'll have some scrap paper on the back of your reference sheet, and also on graph paper you can do this out, and there should be even enough room on your exam to do it. All right, so write down what you need to. Come in with questions tomorrow if there's anything here that's confusing to you. But I would really prefer that you just rewind it and look at it one more time. Maybe write things down and listen to it the second time and see if you can make sense out of it. Okay, moving on to the second page. So exercise 3 says the heights of 16-year-old teenage boys are normally distributed with a mean of 66 inches and a standard deviation of 3. So that's the first thing I always write down. So I know I have a mean of 66 and a standard deviation of 3. All right. Now it says if Jabari is 72 inches tall, which of the following is closest to his height percentile rank? All right. So again, you can do it a little bit differently without doing so much work. You can say, well, I know my mean is 66. So without drawing the whole thing out, this is just another way to do it. You can say 72 minus 66, all right, is equal to 6, and then we divide that by our standard deviation, which is 3. So we basically get 2 standard deviations above the mean. Okay, so if you think about those 2 full standard deviations above the mean, go back to our example that I have down here at the bottom. I'm going to try and raise it up so you can see it. All right, and maybe I can raise it up here so you can see it a little better. All right, so 2 standard deviations above the mean. And again, this is something you're going to have to draw out or have in your mind. So here's my mean, and if we're going 2 standard deviations above the mean, we're going to be here. So we're going to add 19.1 plus 15.0 plus 9.2 plus 4.4, and we're going to get 97.7%. So, percentage-wise, 98th percentile. Okay, exercise 4. I'm going to slide this down a little bit, and I'm going to move this so I can see exercise 4. And this says the amount of soda in a standard can is normally distributed with a mean of 12 ounces, and a standard deviation of 0.6 ounces. If 250 soda cans were pulled from a company to check volume, how many of these soda cans would be expected to have less than 11.1 ounces in them? So now we can do what we just did before, where you subtract them and divide by the standard deviation, or you can simply look and see what that would look like on your normal distribution, right? That mean is right here at 12. And I'm going to continue, and I'll bring it right back to you. So what I put down here is, let's get a color here so I can see. I put down my mean, which is 12. I added 1 standard deviation here above the mean, and I added 1 standard deviation below the mean, but it tells me 11.1, so I went down 2 standard deviations below the mean, which still didn't give me my 11.1, so I realized that 11.1 falls between those two. So again, remember what those numbers were. Between here and here was that 19.1, between here and here was the 15, and between here and here was the 9.2. So you're going to be adding up 9.2. Okay, before that, it says less than 11.1 ounces. So we want to look at less than 11.1 ounces. So what we want is from this point down, all right? So we want to know from this point down. And I think the easiest thing to do here is take these points. So if I know that from here to here is 50%. So from here to this point is 50%. So if I take let's see if I can do it over here. If I take 50 and I subtract out the 19.1 plus the 15 plus the 9.2, I should come out with the right answer, which is 16.75, which is good because, yes, the answer is number 1 right here. All right? So you can do it the way we did in exercise 3, and you would have come out with minus 2.5 standard deviations from the mean, and then gone right to your minus 1.5 standard deviations from the mean, and gone right to the distribution, which I have right here. All right, that's one way to do it. The other way to do it is make your own. All right, so we're going to take a look now at exercise 5. Exercise 5 says, biologists are studying the weights of, let's pull this down so we can read it, red king crabs. This board is not happy today. My apologies. Here we go. Let's pull this down so we can see what's going on. So, the weights of red king crabs in Alaskan waters. They sample 16 crabs and compile their weights in pounds as shown below. determine the mean and the sample standard deviation for the sample of crabs. So at this point, you're going to go right to your calculator. So hold on, let's pull it up and see what that looks like. Okay, so here they are put into our table. It's one variable statistic, so I do not need a label up at A. I make sure I'm at an empty box underneath 16, which is right down here. I go to menu, I go to stats. It will not let me do it, so let's try that one more time. Escape. Let's try and make this blue box and see if it'll take it now. Menu, stats, stat calculations. There we go. One variable statistics, number list 1. We're just going to hit the OK button, and then we can slide up and take a look at the information they're asking for. So they're asking for our mean, which is 12. This stupid thing does not like to. My apologies. The one on the board is not happy. So 12.5875 is my mean. My standard deviation, this is not a sample. Is it a sample? It is a sample. They sample 16 crabs. So I love that because most of the time we use population, but this is the time that we use sample. So our sample standard deviation is going to be 1.50593. All right, so let's write that down on our sheet, which is right here. So determine the mean and the sample standard deviation. I love that they say that. So the mean, x bar, is equal to, we said 12.5875, so we're going to round it because it says to the nearest tenth. And our sample standard deviation is going to be 1.5 pounds. So it says, why does the sample indicate that the population would be well-modeled using a normal distribution? And it says, explain. Hint, use your calculator to sort the data in ascending order. All right, so basically what you would do is take a look at, and I'm not going to do that right now, but you'd look and see the 11 values lie within the standard deviation of the mean. All right, so if you go within one standard deviation of the mean, it tells you you're supposed to have 68.2%. But we come out with 68.75%, so that's a really good test. I'm just going to show you what I mean by that here on our thing. If you talk about the one standard deviation from the mean, if you add these up right here, you get 68.2% of the data lies within one standard deviation of the mean. And in this population, we get 68.75 lie between the standard deviation and add, so the 12.6 is our mean. Our mean plus one standard deviation is going to be 12.6 and 1.5, which is 14.1, and one standard deviation, and the mean minus one standard deviation is going to be 12.6 minus 1.5, which is 10.1. 11.1? 11.1. My bad. So basically, if you look at your data, this is a normal distribution, okay? C says, assuming your mean and standard deviation for part A apply to a normally distributed population of crabs caught in Alaska, what percent will fall between 9.6 and 15.5 pounds? All right, well, here I would probably do the same thing I've been doing, and it kind of keeps me sane. Now, you could use this, like you could use this piece right here. Let's use this piece, this one here, cover up the one I have. And what I mean by using it is make it a little bit bigger, and we could use this and say our mean turned out to be 12.6. That's right here. One standard deviation is 14.1. The other one is 11.1 right here. And they're saying we have to go between 9.6 and 15.6. So we have to find the 15.6, which is going to be right here at 2 standard deviations, and the 9.6, which is minus 2 standard deviations. So they want to know from here to here. So you're going to add all that up, and you're going to get 95.4%, like we did on the first page here. All right? Now it says a fisherman must throw back any crab caught below 10.4 pounds. Approximately what percent of crabs caught will need to be thrown back? Well, if you look here, because you don't see 10.4 anywhere, but if you actually look between our 1 standard deviation below the mean and our 2 standard deviations below the mean, this number here turns out to be 10.35, which is pretty darn close to our 10.4. So I think that's where that number came from. So they're saying what percentage from here down? So we need all these numbers. So that's going to be 0.1 plus 0.5 plus 1.7 plus 4.4 is 6.7% of the population. So based on our, okay, it says what percent of the crabs. I'm sorry, I thought I was answering a different question. Okay, so approximately what percent, I didn't annotate, of the crabs caught will we need to throw back? And it's used to simply 6.7% of the crabs have to be thrown back. All right, so that's going to be it for today. Like I said, I'd like you to, I know this was long, my apologies, but I'm only going to be doing these videos once in a while. We're trying to get some done in class, but it's really important to make sure, because we are not working on classwork on this tomorrow. This is it. So come in with any questions, come in with where numbers came from. I'll spend 10 minutes going over it before we go on to 13.4 tomorrow. Okay? I really need to subject you as much as stats that I can before we get to the end of the year, and I would like to spend some time reviewing with you. Okay, until next time, we see each other. Always make good choices and be kind to each other.